Okay, I gotta go. Can you please sub for my kindergarten class, please? I'm really busy. I
Sure,
need to,
sure, okay. All right.
What's our Calc class move?
I don't know, it's so weird. We're like a schedule in conflict or something.
Yeah! I'll be your substitute teacher for today. For my calculus students today, we're going to be learning antiderivatives. For my kindergartners, we're going to be learning our ABCs. Yeah!
Why are we with the kindergartners today?
I don't actually know. Your other teacher had to leave in a rush. She didn't actually explain why, so... Yeah, let's get on with it. Okay, so we're going to be finding the function of f of theta from the 26th antiderivative of f theta equals sine theta. Alright, so for my kindergartners, do you all know your ABCs?
Huddle!
A, B, C, D, E, E, F, F, G, H, I, J, K, L, M, N, B, Q, R, S, T, U, V. What's the end of the alphabet? Z. And break. Okay, class, so moving on, we're going to be finding the 25th antiderivative from here, which would be f 25 of theta equals what?
Negative cosine theta.
Precisely. Negative cosine of theta plus, now kindergartners, what's the first letter of the alphabet? Yes?
A.
Exactly. Cosine theta plus A. The next part of this problem, to find the 24th derivative, antiderivative, sorry. So, it would be negative sine from here, because we're moving backwards, plus A theta plus the next letter of the alphabet?
B.
Exactly.
Show off.
Who's that?
Oh, that's Sarah. She's in our class. She's a fuck off.
Right. Well, moving on. So, for the next one.
Wait. Hey.
Yes?
Sit down. I have a thing. Wait. Okay. So guys, this is a pattern, right? You see? It's a pattern. So it goes sine, negative sine, cosine. And then back to sine. Because the derivative of sine is negative cosine, and then the derivative of negative cosine is negative sine, and it goes like that. So I'm just gonna put this here, and then I'm gonna go back. Do you guys get it?
A, B, C, D.
You guys are stupid. I'm gonna go back over there. Phi theta plus
Z!
Z. I beat you. I win.
But Sarah, everybody wins in calculus.
Yay!
So, as the calculus winner, I'm here to tell you how we actually did this. So, here's a little bit about how antiderivatives work. So So you start with the derivative of a function. Let's say it's the 26th derivative, like we did. So we have f26 prime of theta equals sine of theta. So that's what we're going to be working off of. So we want to find the antiderivative of this function. So that would be f25 prime of theta equals, and then we want to find the antiderivative of sine. So you kind of just have to know that from, I made that little handy dandy chart earlier. So the antiderivative of a sine is going to be a negative cosine. So you have negative cosine here of theta, and then we need to add a constant at the end here, because if you have a constant, the derivative of a constant would be 0. So as you go along, it sort of follows this pattern, and your constants just gain more exponents, I guess. And so that's how that goes, and that's how we got this big old thing right here. So the sort of definition for this is, let's say you have x to the n, and you want to find the antiderivative of that. So that would equal x to the n plus 1, because when you take the derivative of something, you subtract 1 from the exponent. So it'd be that. And then it would be over your exponent, so that it cancels out when you try to take the derivative of it. So that's about it. So that's how this whole thing works.
Can I go home yet?